going to talk about is recapping about balancing equations. And remember, balancing equations, remember the Mr. Bill phrase, it's a lot of BS, that you have to make sure that both sides are balanced. Okay? So remember, if you have 5 on the left, you need to have 5 on the right. Now, the purpose behind that for balancing is this one called Law of Conservation of Matter. So all the matter that's out there in the world, basically you're just transforming it, going back to kinetic and potential, you're just transforming it from one form of matter into another. You don't create it. You don't really destroy it. You're just changing its form. So if I have 5 items on the left-hand side of an equation, I need to have 5 items on the right-hand side for it to be balanced. Later today, we're going to try to set up a small little activity where we will go in there and actually review that. Now, there are 4 types of reactions that we're actually going to look at and actually identify. The first type is synthesis. The second type is decomposition. The third type is single replacement. And the fourth main type is double replacement. Now I have a slide for each of these where we will look more in depth. But there are some 2 special types of reactions there. One of them is called combustion, where you combine things with oxygen and it explodes. Think of the word combustion. It explodes. And the byproduct of a combustion is carbon dioxide and water, believe it or not. After things explode, those are things that are evident. And another one's neutralization, and we're going to look at that one more in depth on our next unit. We work with acids and bases, mixing things together. Alright, so let's look at this first one called synthesis. Synthesis is where I take element A and element B and I combine them to form one thing. That's sort of like me and Mr. Bill back in the day, dating. We dated, okay, and then we got married. So now we are a married couple, okay? So that's 2 things, arrow, and it relies, or the reaction ends up with one product, okay? So emphasis is 2 people becoming a couple. All right. Now, decomposition would be A and B. Here's a happy couple sitting on the bench, and then the error relates to where maybe something was said and the 2 of them break up. So decomposition is things breaking up. So you have one thing on the left and it reverts to 2 or more things on the right-hand side. So it's the breakup. Okay? Now, another one is called single replacement. Now, watch very carefully. Let's look at this equation up at the top. You have 2 plus signs. Look at that, 2 plus signs. Okay? But the thing is, there is an element and then a compound yields an element and a compound. What happens in a single replacement, an element comes in, kicks out, and it's usually the positively charged, the very first thing written. It will kick it out and then take its place. This is sort of like cheating, okay? Here I have a happy couple. This person comes in, messes with the happy couple, and now they cheat, and now they switch who they're actually going with. And the poor Frank, if you look at this little diagram right here, poor Frank is left on the wayside. It's also where you're dancing and someone will cut in dancing and switch partners. Okay? Double replacement on here is where you have 2 different compounds, and then like here we have in this one, we have Joe and Mary together, and then Josh. Who is this? This is Josh and Sue. Okay, but then in the instance, then they will switch places. So Joe and Josh then will switch places, and now Joe is now with Mary, and Josh is now with Sue. Okay, all of them combined together, and they're switching partners. Okay, now let's try this right now. Let's look at these examples. Key one, for the first one, I got an error right here, and remember my rules say on this one, okay, let me get the pen color. Let me make sure I got my pen color. First of all, remember I said draw a line down that that arrow sign. And then the other thing, draw circles around your plus signs. In this case, I have 2. So that means I've narrowed it down because I have 2 plus signs. That means it's either going to be single replacement or double replacement. Now the other thing I look at is ask myself, is this a compound or element? A compound, remember, is 2 or more things chemically combined. This one right here would be a compound, and this one right here would be a compound. So far, so good. We're on the road to a double replacement. But let's double check on the back side, on the right hand side. And again, there is a compound, and there is a compound. So when I have the 2 right here, I got compound plus compound yields compound and compound. They're switching partners, therefore this first one is a double replacement. All right, let's look at the second one. Draw a line down your arrow sign, okay, to split it left to right. And now I want to circle the plus signs, okay? So when I do that right there, I only have 1 plus sign. Okay, and then I ask myself, do I have one thing on the left-hand side or one thing on the right-hand side? And then I look at it this way, I got one thing and it's on the right-hand side. Okay, that means that this is synthesis. 2 things combine to form one product. Okay, so this is synthesis. All right, let's look at this third one. Again, draw your line down the arrows, and I circle my plus signs, and I have 2 again. So that means it's either double or single replacement. Okay, I can narrow it down. Now I come over here and I ask myself, do I have a single element or compounds? And PB, capital then lowercase, that is a single element. Okay? And then FeSO4, that is a compound. Ooh, there you go. Element compound. Not quite what we see in number 1. So when I look at this one up here, that is a compound, PbSO4. And Fe by itself got kicked out to the curb. That is an element. Okay? So that would be a single replacement. Then the last one, number 4, when I look at this one, CaCO3, oops, and I forgot to draw my line down the arrow. That right there is a compound, okay? And then I look on the right-hand side, I got a plus sign. So it's one thing broken down into 2 smaller things. So I got a compound, and then I have an element. But the bottom line is I only have one thing on the left-hand side, and that would be decomposition. Okay? Now, here again is the combustion, the special one. All right, so what you have in a combustion, the key thing is, and let me get my pen on, and let's do this in blue. First of all, I have oxygen on the left-hand side, okay, as one of the reactants. So here I have a gas, and this actually is methane gas right here, and it combines with oxygen. And what it yields is CO2, carbon dioxide, and water. So remember, your products are always these, carbon dioxide and water, in a combustion reaction. Okay? All right. Thank you very much. We'll practice some more worksheets on identifying those reactions.